Hello friends, good day to everyone, and this is Varadha Qureshi on my channel Network Lessons. And today in this video we are going to see how mpls is used in the service provider core, and this is one of the use cases wherein the ISP uses mpls in Pure ISP actually. So let's see what happens. For this you should see my earlier video which I've created, in which I've shown how to create the mpls core and using EIGRP as the underlay protocol, and then I run mpls on all the four routers R1, R2, R3 and R4. And in this video I'll take the configuration from there and I'll extend the configuration on R5 and R6 that are the CEs, and R4 and R1 that those are the PEs, like the provider edge, right? So what we'll do in this video is we are going to run BGP here and here, and likewise here and here. So these are the customer edge routers, right? So I want to propagate my 6 network via this to this router. So they should know how to reach this network, right? But then I don't want my provider internal routers to know about my addresses. So they should not be able to reach my internal address, right? Right? But my sites should be able to communicate to each other, right? There should be communication on both sides. So how to achieve this in a service provider environment? We'll see that. And MPLS helps a lot in this. So first the uh, this thing is achieved because of MPLS running in the core of the service provider, right? So the service provider now doesn't need to have a full mesh of BGP, right? So you can see here I'll run iBGP between these two and eBGP here between the CE and PE. Okay, let's do this and let's see this in action. Okay, and then we'll understand. I'll just close this pen. Okay, now so let's go to R1 first, and I think R1 is running. Yeah, already running, and then R4 I need to go to R5, and no. So this is my R5, and I'll go to R6 as well. Right here, R6. Okay, no. So R6 is done. So let's configure R5 and R6. So I'll just continue with the configuration that I did. Enable config T. Let's get the host name R5. No IP domain lookup in case I accidentally type some wrong commands. And then what we'll do is on R5 I need to enable this interface E00. Okay, then on R1 I need Ethernet 0/0. Let's assign IP address 192.1.15, right? 125, 125, yeah. Dot 5 would be this side, 255.255.255.0, and then no shut, and then interface loop back 0, right? IP address 5.5.5.5 and 255.0.0.0. So that's it for now. Uh, and right. Okay, so on R5 let's paste this, and on R5, right, we'll do this. So okay, there is IP add, IP add. Oh, mistake. So that's what I didn't want. See? Okay, done. R5 is done. Let's copy the same thing for R6. Let's do the same thing for R6, right? R6, what we will have is we'll change this to 6 and then Ethan. Is it 00? Oh, 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 my mistake. This should be E01, right? So guys, E01. So I need to go to R. Oh, I'm right. Sorry. I'm looking at R1. Okay, for this is correct. This should be E00 on R6, and then the IP address should be 46.6, 46.6, and this should be 6.6.6, right? So let's copy paste this thing on R6, right? Copy, and let's go to R6 and paste it. So done. So I should be able to ping. Okay, I'll not be able to ping because I don't have that interface up on R1 and R4, right? So I'll go to R1 and on this interface. So I'll not be running interface on interface this. So not this one. So let's go to the top one where we configure the basic. Okay, here. So I have here and then interface Ethernet 0/1, right? IP address, what is that? 192.1.15.1 255.255.255.2.0, no shut, right? So I'll copy this. I'll copy this and okay, let's paste this on R1. R1 is R1 here. R1. So this is enable config t and then done and right, and I should be able to ping 192.1.15.5, right? So that should be up. Okay guys, so I should be able to ping 192.1.15.1, right? That's my next hop. Okay, great. So I need to configure R6 as well. So for R6 I will have this okay, R6 is already configured. Show IP interface brief. Okay. So I need to configure R4. Let's go to R4. It is R4, R2, R3, R4, right? So R4, this is the interface ETH1, and this should be 46.4, right? So yeah, so I need to copy this and go to R4 and paste this, right? And show IP interface brief, and I should be able to ping .6. That is my next router, right? R4. So now what we'll do is so let me show you the routing table for R6. Show IP route, right? So I don't know any of the routes that are internal to the ISP, plus I don't know any routes that is on my other side, right? The AS500, right? 5.5.5. So what we'll do, we'll run eBGP between R4 and R6, right? So for that, okay, let me grab my node and go to the bottom and say configure eBGP between R6 and R4, comma R1 and R5, right? This is eBGP, and iBGP between R1 and R4, right? Correct. So let's start with R6. Let's start with R6. So the first command would be router BGP and the AS number, that is R600, right? Then what we'll do is the neighbor command. Neighbor, who's my neighbor? It's the 192. If I want to run on the loopback, then I have to again define the update source loopback 0, and also the TTL value needs to be incremented, right? By the command ebgp multi-hop, right? So I'll not do that. I'll just run ebgp on the physical interfaces. That is the next hop, directly connected cable, right? So that is 192.1.46.4, and the remote AS is 100, right? And then that's it with the with the ebgp. My next hop would be updated, and also I need to advertise the network 5.0.0.0, right? So that is this write command. So I'll paste this on R6, and that is this one, right? R6 done, and I'll go to R4. Where's my R4? So I'll copy this like this, and I'll paste it on R4, right? R4 I need to do router BGP 100, and my neighbor would be 6, and I'm not okay, so I'll not advertise any routes on R4. So let's go to R4 and okay, enable config T, and then paste this, and right, I did that. Show IP BGP will show me the summary will show me the neighbors, okay? And there is some issue that I want to see. Session neighbor 4 IP custom BGP to remove the session notification received. Okay, let's see what is the issue on this. So let's see, I've disabled the BGP on this router, and on this router R6. Okay, I'm actually first of all I'll do, okay, here config T. So on R6, right? So router BGP is fine, and no network this, and I have network 6, right? And my neighbor 992.1.46.4 remote AS is 100, right? That is correct, because if I go here, do show IP interface brief, I can see this is 46.6, and I am able to reach 46.4, right? So that is done. Now here we'll do router BGP 100, and then neighbor dot 6, right? And the remote AS is 600, and right. So this should bring up the neighborship. Show IP BGP summary, right? So the neighborship is up. I don't know what was the problem here. Okay. On R4 should be 100, and the remote should be 600. So my remote AS was wrong here. So I have received and show IP BGP. If I see, I'll see that I'm receiving the 6 from this, right? So likewise, we'll enable this on R5 and R1. So R5 we will go with 500 and 192.1.15.1 as the R1 and 100, and yeah, network 5 is fine. Here network 6, right? So I'll paste this in R5. Okay, paste this in R5, and then R4, right? So I need to copy this, and R1, sorry, this is R1. So 100, and the neighbor would be 15.5. remote AS is 500. Copy on R1, paste it on R1, right? This is R1, enable conf p, and R1 goes like this. Show IP BGP. Summary will show me the neighbors. I don't see the log. Yeah, it's up now, and I'll see show IP BGP, and I should see 6 here. Sorry, 5 here. No, it's not there. It should didn't it? Yeah, I did mention this, right? Let's see once again. It should come up. Show IP BGP. I'm coming. Show IP BGP. Let's see. Am I? Yes, I am sending this, and I should receive here. Not receiving. Clear BGP neighbor. Here BGP. All right. What storage? Is IP BGP something like that? Yeah. Okay. Start soft. Let's do this, and it should push the configurations on R1. Okay, so R1 is receiving this. So now that we know we have connectivity between R1 to R4, that means R1's loopback can reach R4, and R4 can reach loopback of R6, right? Oh, sorry. R4 can ping 6, right? Done. So our objective is that 5 should reach 6, but nobody from inside our this ISP core should know about our routes. So for that, what we'll do is we'll run IBGP between R1 and R4. Okay, config T. Let's do this on the notepad first. So configure IBGP between R1 and R4. Yes. So for R1, let's begin. Our router BGP is already running 100. Okay. Neighbor. So I'll go down. Neighbor. Who's my neighbor? I'll go with the loopback for the remote AS is 100. And then again, I need to specify the first thing is next hop self, so that next hop is changed to myself. Okay, that is for 1.1.1 because R4 knows how to reach 1.1.1, right? And also I need to specify when I'm sending the BGP session packets, right? It should be initiated from my loopback, that is 1.1, because R4 will be creating the session with my loopback, so it should match, right? His neighbor command and my source should match. So neighbor this update source loopback 0. So that is the command that we need. Right, and that's it. That's done. And and right. Sorry, and right. Oh, right. So I'll do the same for R4 as well. Let's work on R4. Same neighbor would be my 1.1.1.1. Everything would be same apart from the neighbor. Right, so this is for R4, right? So let me paste this on R1, copy, go to R1, and if everything works fine, I should have a neighborship with R4 and R1, right? So I'll do this. So the neighborship should come up. Now go to R1. Yep, the neighborship is up. So if I see show IP BGP summary, I can see I'm neighbors with 4 and I have exchanged a prefix 1. So that would be obviously 5. For R4 it would be 6 and 5, right? For R1 it would be 6. From R1 it is sending 5 prefix to R4. From R4 it's sending 6 prefix to R1, right? So show IP BGP, if I see, I should see 6 coming from my side and 5 I'm learning with IBGP, right? You can see, and it was generated in 500. So AS path attribute is getting updated, and also the next hop is 1.1.1.1, that is R1. Now the magic that I want to show you is, let's check on R6. Show IP or route. You can see I'm learning 5, right, as a BGP route. And now you tell me, will I be able to ping 5.5.5.5 from 6.6.6.6? And let me show you R3 show IP route. Doesn't know anything about 5 as well as 6. So will this ping work or not? Let's try. Source of loopback 0, that is my 6, right? So guys, ready for this? And it's working. How's that happening? This is with the help of mpls in the core, right? And the IBGP pairing that we are having. So guys, you need to practice this, and basically how this is happening, let's try to understand this, right? So from R6 a packet is generated with okay, with R6 has a packet source of 6.6.6.6 and destination of 5.5.5.5, right? Correct? Okay, so this packet is generated. This is an IPv4 packet, right? And on the layer 2 it will have 0x0800, right? So checks the routing table. R6 show IP route and gets to know 5 I learned from 192.1.46.4, and when I do an R 46.4 I have the MAC address. So source MAC is this, destination MAC is this, and the packet is sent to R4. Let's go on R4 and see what R4 does. So R4 show IP route. So for show IP route for now, so now R4 has a route, has a packet that is destined for 5. Do I know 5? Yeah, I know 5. That is via 1.1.1. So it does a recursive lookup and checks. How do I know 1? It says I know 1 via EIGRP, and it is via R3, right? R3. So when it does the lookup for show IP route, so we need to do the sef, show IP sef for 192.1.34.3, right? This one, it's an attached network. 34.3. Yeah, this is the one. So it's an attached network, right? But then the original packet is, now there's another packet that is going to 1.1.1, that is next hop, right? It's via this. But then when I see show IP mpls bindings, right? Sorry, mpls ldp bindings. So for 1.1.1 I should have something, right? Okay, so I have labels. So now I'll not check the routing table, I have go with labels, right? Because before L3 it comes L2, this 2.5, right? So I'll check labels and I have a label and I'll send this as a label of 3000 to R3, right? R3 receives this as 3000 and go on R3 show mpls ldp bindings. So for 1111, what do I have? I received 3000, right? So whenever I have 11111 and that is 3000, I need to send this to 2. Again, how did it know? Show IP route. Which see 111 is via 2, right? So this takes 2, this one 2000, send it to R2. R2 again checks, it will find 1111 is via R1. So send the traffic to R1. So when R1 gets the traffic, right? Show IP route. Now R1 knows 5. And also till here R2 would have done the pop, right? PHP. It would have removed the label and send this to R1 as an IP packet. So so R1 knows 555 is via 15.5, and if it checks the ARP table, it will get the layer 2 MAC address rewrite for 5 source MAC. So it will send the packet to R5, and this is how the communication happens. Let's try doing a trace route from R6 and see this magic happening. Okay. Trace route 5.5.5, source of loopback 0. So see, 3000 is attached from, I think this is from 4 because 3000 was sent, and then from 2. So I don't know what's the problem with this. This is an issue with EVNG. So the pop label is not being shown. So this is R2 doing the pop, and you can see R1 has received this as a normal packet, right? IP packet. But you can see MPLS label being attached, and here it should show you the pop. So yeah, this was it for the video, and I'll paste the configurations in the description for the previous video as well as this one. So if you want to practice, you can do that, and also if you want to know about the basic MPLS, you can check out my other video that I posted before this video. So guys, yeah, I'll again post some advanced MPLS videos whenever I get time. Yeah, so thanks for watching my videos, and please do subscribe to my channel and like my channel, and please do comment what do you like in my channel and what else do you want. I'll try my best to record those things and provide it to you. Okay guys, bye bye, happy learning.